Okay, so today what we're going to be working on is the binomial expansion. So I would like you to put me on pause and do the try this and then come back and check your answers. Okay, so hopefully you tried these binomials here with the exponents. And let's see what we got. So we have here the first one, which says x plus y to the 0 power. Now remember, anything to the 0 power, remember that is equal to 1. So this is just 1 here. All right, so the next one here, which is x plus y to the first power. So remember, anything to the first power is equal to itself. So x plus y to the first power is x plus y. Okay, the next one, which is x plus y squared. So remember, x plus y squared means to do x plus y. So that means to do x plus y times x plus y. So we will double distribute. So x times x is x squared. X times y is xy. Y times x is xy. And y times y is y squared. And then when I clean it up, I get x squared plus 2xy plus y squared. All right, so now if I want to do x plus y to the third power, so that means I have to multiply it out 3 times. So that would mean I would have to do x plus y times x plus y times x plus y. So I already know what x plus y times x plus y is. That's x squared plus 2xy plus y squared. I got that from here. And now I got to multiply that by x plus y. So I have y times y squared is y to the third. Y times 2xy is 2xy squared. Y times x squared is x squared y. And then when I multiply x now, x times y squared would be xy squared. X times 2xy is 2x squared y. And x times x is x cubed. So when I add them down, I get x to the third plus 3x squared y plus 3xy squared plus y cubed. So now what if I wanted to keep going? What if I wanted to do like x plus y to the fifth power? Well, that's too much. So what we do is we could either use Pascal's triangle or combination. So let's write that down. So right here at the stars here, we're going to put, we don't want to have to. We don't want to have to keep multiplying, so we can use Pascal's triangle or combinations. Okay, so let me show you what Pascal's triangle is. All right, so Pascal's triangle is a triangle of numbers. Now, it looks like a bowling pins, how bowling pins are set up. So at the top of your pyramid is always going to be a 1, and down the sides of the pyramid are going to be 1s too. So at the top of your pyramid, we have a 1. Okay, so a 1 at the top of the pyramid. Down the sides are going to be 1, so I'm making a pyramid. So now this side here will be 1. Now to get this number here that goes in the middle, I add these 2 numbers above it, which that's going to be 2 because 1 plus 1 is 2. All right, so I have a 1 here, 1 down the side. To get this number and this number, I add these 2, which is 3, and I add these, which is 3. And then it's a 1, 1. And then this number here, here, and here. So this is a 4, 6, 4. Okay, let's do it again. So I have a 1 at the ends. All right, now in the middle. So I have a number here, 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 and here. So this is 5, 10, 10, 5. All right, we'll do one more. So 1's at the end. All right, and then I need the middle. So I need one here, 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 and here. So this is 6, 15, 20, 15, and 6. Okay, so now what do we do with that? How does that help me? Well, what these numbers do here is they give me my coefficient. So let's write that down. So hopefully you have this here up in this section. Hopefully you didn't write it too big. All right, so this here, those are your coefficients. And they are your coefficients for each exponent. So for the first one, this would be for an exponent of 0. This one would be for exponent of 1. This would be exponent of 2. This would be exponent of 3, and so on, right, going down. So this would be exponent of 4, exponent of 5, exponent 6. All right, so now how do I use that? So I'm just going to move this down a tiny bit, or try to move it up, actually. Okay, so what you're going to do is, when you expand the binomial, is that each term, or each coefficient, so each coefficient that's up here, when you do, depending on which exponent, is going to get xy. And you're going to give x and y an exponent. You're going to start the x with the exponent that the binomial has, and that's going to go down to 0, and the y will start at 0 and go up to the exponent. All right, so let's take a look at the first one. We have xy to the 0 power. So for an exponent of 0, my coefficient is 1. So I only have then one term, right? So it's going to be xy, right? Coefficient is 1, xy. And then your x is going to start at whatever exponent you have here, which is a 0. So it's going to be x to the 0 power. Now y always starts at 0. And it'll go up to the exponent. So that's it, because my exponent is 0. And then anything to the 0 power is equal to 1. All right, so now let's do x plus y to the first power. So here's my exponent of a 1. So I have two coefficients. So it's going to be, let me get rid of this. So it's going to be 1 xy plus 1 xy. Your x is going to start with this exponent, and your y will start with 0. So it's going to be x to the first power, y to the 0 power. And then for the next term, your x will go down, your y will go up. So it'll be now x to the 0, y to the first. Okay, now we simplify this. Okay, so we have here anything to the 0 power here is equal to 1. So this is just 1 times x to the first times 1 is just x to the first. And the same thing over here. This is 1 times 1. This here is 1 times y. So it's plus y. So my answer is just x plus y. All right, so let's try the next one. All right, so x plus 2 squared. So we have x plus 2 squared. Let's take a look at Pascal's triangle. For x plus 2 squared, it's going to be 1, 2, and a 1 here. So it's going to be 1 xy plus 2xy plus 1xy. Your x is going to start with an exponent of a 2, and your y will start with 0. So it will be x to the second power and then y will be to the 0 power. Now your x's will go down as your y's go up. So it'll be x to the first, y to the first, x to the 0, and y to the second. So now let's just simplify this. So my y to the 0 is 1. So I'll be left with, right here, I'm left with just x squared. Plus, x to the 1 is just x. Y to the 1 is just y, so I'm left with plus 2xy. This becomes 1, so it's plus y squared. All right, so now we're going to work on x plus y cubed. All right, so for x plus y cubed, my coefficients are 1, 3, 3, 1. So it'll be 1, so it's for this one, xy plus 3xy plus 3xy plus 1xy. So we will start the x with an exponent of a 3. And now my x's go down. So you could go do all the x's if you want. So this will be a 2, this will be a 1, and that'll be a 0. My y always starts at 0. So it'll be 0, 1, 2, 3. And that goes up. So let's take a look at the first term, right? So this here is a 1, so I'm left with just x to the third. So I have x to the third here, plus 3x squared y, because y to the first is just y, plus 3xy squared, plus, this becomes 1, so I'm left with just y to the third power. So that is expanding the binomial without actually multiplying everything out. All right, so now let's do x plus y to the 5th power. So I'm just going to move everything up a little bit. All right, so x plus y to the 5th power. So here's my coefficients, 1, 5, 10, 10, 5. All right, so it's going to be here 1xy plus 5xy plus 10xy plus 10xy plus 5xy plus 1xy. All right, now my x will start with a 5. So it'll be 5, 4, 3, 2, 1, 0. And my y will start with 0. 1, 2, 3, 4, and 5. All right, so my first term here, so my y to the 0 is 1, so that's x to the 5th, plus 5x to the 4th y, plus 10x to the 3rd y squared, plus 10x squared y to the 3rd, plus 5x y to the 4th, plus this becomes a 1, so it's just plus 5 plus y to the 5th. So I just did x plus y to the 5th power, which is really x plus y times x plus y times x plus y times x plus y times x plus y, and it was so easy by using Pascal's triangle. All right, so now take a look at this guy here. So if you take a look at this, the b to the second minus 3, we can use Pascal's triangle. It just gets a little bit more complicated because of b to the second and the negative 3. So we're going to use combinations. So this is more complicated. Not that it doesn't work. It does work with Pascal's triangle. So we're going to use combinations. Okay, so let's flip it over. Okay, so there is a formula for this. The combination formula is NCR, and I'll tell you what all this is. P to the R power, Q to the N minus R power. So just so you know, this, whatever number is here is the same number that's there. And then when you subtract these two, that's what goes in up here. Okay? So the C button, there's the C button in your calculator, so you don't have to actually do that math there. So I'm just going to rewrite this. So there is a C button in your calculator. So you're going to hit, before I tell you what everything else is, I want to tell you where the C button is. All right, so you're going to hit math. So this is for the C button. So you're going to hit math. And then you're going to go over to PRB. PRB stands for probability because this is a probability formula. And then you go to number 3. Okay, so let's just try practicing putting this in. So let's try practicing 5C3, 2 to the 5th, and 3 to the 2nd. So what you're going to do, so hit clear on your calculator, you're going to type 5 in first. Type that number in first, and then go to math, probability, number 3. Okay, and then it should look like that on your screen. Then type 3 in, and then you could just hit enter, and you get 5C3 comes out to be 10. And then you have this here, 2 to the 5th power, so that's times 32. This is all times in here, times 32, and then 3 squared is 9. And then you multiply those together and you get 2880. Okay, so now let me tell you what the N, the R, the P, and the Q are. All right, so let me rewrite this again. So it's N, C, R, N, C, R, P to the R, Q to the M minus R. So N is your exponent. That's my clock in the background going off. All right, R is your exponent down to 0. Your P is the first term, and Q is your second term. Okay, so let's do some problems now. So the first problem we're going to do is x plus y to the 4th power. All right, so on the side, I want you to write down what your N, your R, your P, your Q are. All right, so we're going to start by writing down N. So N is going to be your exponent, which is 4. R is your exponent down to 0, so it's going to be 4, 3, 2, 1, 0. P is your first term, which is x. Q is your second term, which is going to be y. So now we're going to use the formula N, C, R, P to the R, Q to the N minus R power. All right, so we're going to start with 4C4. So it's going to be 4C4, right? So I start with 4, it's my exponent, and then I go to 4. First term is x, raised to the R power, which is 4, times my second term, which is y, raised to the N minus 4. So what you're doing is you're subtracting these. So 4 minus 4 is 0. So this is 0 here. These two numbers here always have to add, these two numbers here always have to add up to be this number. So once you know this is 4, this has to be 0. All right, and then we're going to do the next one. So the next one's going to be 4C, sorry. The next one is 4C3, x to the 3rd, y to the 1st. The next one will be 4C2, x to the 2nd, y to the 2nd. The next one will be 4C1, x to the 1st, y to the 3rd. And the last one will be 4C0, x to the 0, y to the 4th. All right, so now we're going to do each one of these. So you're going to plug in your calculator 4C4. 4C4 comes out to be 1 times, and then I have x to the 4th. Y to the 0 is 1 times 1, which is x to the 4th. All right, on to the next one. 4C3. 4C3 is 4, so you plug that in your calculator, times x to the third times y to the first, which is 4x to the third y. 4c2 is 6 times x squared y squared. So that's 6x squared y squared. 4c1 is 4 times x to the first times y to the third, which is 4xy to the third. And 4c0 is 1, x to the 0 is 1, and y to the fourth, which is just y to the fourth. Now you can't stop here, you have to finish this up. So what you need to do is you have to string this along and make it a polynomial. So what you would do now is you would start with your first term. So it'll be x to the fourth plus 4x to the third y plus 6x squared y squared plus 4xy cubed plus y to the fourth power. All right, so let's try the next one. So that was basic because it's just x and y. All right, so let's try the next one. Okay, so let's write down the formula. NCR, P to the R, Q to the N minus R. All right, so N, let's write down all of our information. N is going to be 3 because that's my exponent there. R is your exponent. Sorry, N is 3. R is your exponent down to 0. 3, 2, 1, and 0. P is your first term, which is b squared, and Q is your second term, which is negative 3. All right, so let's start with 3C3. First term is b squared. You have to raise that to the r power, which is 3. And then it's negative 3 to the 0 power. And then it's 3c2, b squared squared, negative 3 to the first. 3c1, b squared to the first, negative 3 to the second. 3c0, b squared to the 0, negative 3 to the third. All right, so let's see what we have here. 3c3 is 1. Now this here, b to the second to the third. Power to a power, you multiply the power, so that's b to the sixth. Anything to the 0 power is 1, so that's 1. So I get b to the sixth power. All right, next one. 3c2 is 3. b to the second is b to the fourth times negative 3. So now I have negative 9 b to the fourth. Next one. 3c1 is 3. b to the second to the first is b to the second. Negative 3 squared is positive 9. So that's positive 27b squared. 3c0 is 1. b squared to the second power is 1 because anything to the 0 power is 1. Negative 3 to the third power is negative 27. So I just get negative 27. Now notice how my terms went. I went positive, negative, positive, negative. That'll always happen when your binomial is a negative. It'll always start off with a positive and then go to a negative. It'll go opposite signs. All right, so I just have to finish this up and write the expansion. So my first term is b to the 6 minus 9b to the 4th plus 27b squared minus 27. That'd be my final answer. Okay, so that is it, and we'll practice in class tomorrow. Have a good night.